Might as well start recording now. So yeah, so you guys will have access to all those things. You can pull those things up. You can print them off if you want, if that's a little bit easier for you to work with the equations during your midterm or during your final. I've got no problem with that. And we'll get a study guide next week. So does anybody have any other questions before we start? All right, let's see. Let's spotlight my video here. Where do we want to go ahead? Oh, so today we're going to deal with some machinery management stuff. And you guys should have this in your Canvas. Everything should be live. I'm going to kind of run through. There's a little PowerPoint talks about machinery management. And kind of what it is and what we need to deal with. And this is probably a little bit more relevant to you guys, especially for some of you that potentially might be managers of some farms and stuff like that. I don't expect a lot of you are going to be driving tractors and operating that stuff. If you're getting a college degree, you're probably not just going to be jumping on a tractor and disking a field. Not to say that you're not, but you're probably going to be a little bit more involved. Even if you're like an owner operator, you might be jumping on tractors, but you're probably going to have employees and different stuff. And the machinery management really kind of deals with some of the things, some of the aspects that we need to kind of think about when we are operating equipment. So excuse me. So when we think about machinery management, we're basically, talking about, utilizing the equipment that we have, and a lot of the operations kind of, as we've seen kind of throughout this semester, the different operations with the harvest, the rippers. I don't know if we've done any disking or anything like that, but, kind of the tillage equipment, the different stuff that we have, that we're going through. A lot of the operations in a farming aspect and primarily dealing with like plant science stuff, not necessarily, I mean, it is an animal science, but it's not, I guess it's just more prevalent in the plant science side of things. If we're trying to plant, if we're trying to disc, if we're trying to prep a field, machinery is a huge aspect of what we do. It used to not be. We used to do things by hand, but you're never going to be efficient that way. You're never going to be able to, get things done, with large acreages and stuff like that. And so equipment is a pretty vital part, of, any kind of plant operation, and even animals, right? If we're feeding animals and doing those types of things, they are pretty vital, but there's a lot of other aspects when we deal with the animal sides that doesn't necessarily involve, tractors and stuff. When we deal with machinery, we can have cost up to $200 per acre a year for the machinery, for the operations, the fuel and stuff like that to kind of go through a field. That's just kind of a general rule of thumb. Different operations, different stuff. That number may be higher, it may be lower, but that's typically what we're going to spend. The only thing that is more expensive than machinery costs is land costs. So to purchase land, to have that kind of stuff, it's pretty expensive. But beyond that, our most expensive cost that we're going to deal with on, most farms is going to be our machinery, which on average is about 50% of those costs. Labor costs, right? 11%, fertilizer, seeds, chemicals. You can see those things are drastically different, from the machinery costs. Okay. Again, this is aside from land costs. Land costs are obviously going to be more expensive, but the next most expensive thing that we deal with is the machinery, right? And so taking care of this stuff, making sure that way you were utilizing these things, to their maximum potential, so that way we get the value out of it, is going to be important. Labor costs used to be a little bit higher, but as we get more and more machinery that can do things mechanically, we reduce that labor cost down. In some, situations, in some areas, labor costs are really high because we don't have the ability to, run machines through that. I don't believe, and I could be wrong, but I don't believe like strawberries, harvesting strawberries, I think that's all done by hand. I don't think there's a machine that we have. If there is, it's not something that is like readily available to the industry. And so a lot of that, a lot of the strawberries, right, because we're harvesting and doing those types of things by hand, those costs are going to be up a little bit higher, and the machinery costs might be down a little bit. But a lot of operations where we can do that mechanical harvesting, and we can run through and disc and spray and do all that kind of stuff with machines, it really reduces our labor costs because we have one person that's going to be driving a tractor versus 10 or 15 people that are going through a field doing the same amount of work. So the labor costs have kind of gone down, as the machinery costs kind of go up. But sometimes the machinery costs actually reduce the labor cost quite a bit, which is why we do, why we run tractors through fields and different things. Some of the things that we need to kind of think about is if you're like a farmer or if you're working for, somebody and you're managing stuff, how much equipment should be owned? How many tractors do we need to have? Okay. What, it depends on the size, depends on the acreage, depends on what you're doing. Do we need large tractors that are 150, 200 horsepower, or would a 50 horsepower or an 80 horsepower work for what we're doing? Okay. Those things are really dependent on the operation. Are we doing, row crops? Are we doing, orchards? If you've got orchards, you're not going to be or vineyards, you're not going to be running a tractor that's got 200 horsepower because those things are way too big to even fit in the rows. But if you're doing kind of some field crops, you may have a tractor that is pretty large that's going to do that. Um, are you going to use a custom operator? Okay. Or are you going to do these things yourself? If you think about like almonds, for example, when we kind of, see all the equipment that we have for almonds and all the specialized equipment, like the shakers, the sweepers, the pickup machines, that's a lot of equipment to use really one time a year. Do you have enough acreage to basically supply that? Or are you going to say, you know what, we need to hire a custom operator because I only have 100 acres or 200 acres and it's just not going to justify the purchase of that equipment. That stuff's not cheap, right? General tractors that we have, those ones obviously are going to be a little bit different. You might have something that can be used for a lot of different operations, for some disking, for some spraying. You might be using this thing throughout the whole year, and so that's kind of some things that we got to think about. How often do we trade equipment in? Do we run a tractor into the ground and do we just let it kind of break there and then just die in our yard, or do we get rid of it? This is very similar to if you think about like a car. Most of you, I think, have cars and you drive cars. Do you run these things down into the ground and have nothing left, or do you trade this in when it still has some value? Tractors are very much like cars in the fact that they have a lifespan, right? It's equipment, it's machinery, it will break down over time. And how much time are we going to spend with these things before we get rid of them? Should we repair equipment? Sometimes things are going to break, especially as it gets older, or do we just trade those things in? And then how do we keep fuel costs down to a minimum? That's obviously something that's, it's a big cost when we talk about machinery, is running this stuff. Have you guys ever watched what the heck's the show? Gold Rush. If you ever watch Gold Rush, you've probably seen that they're going through hundreds and hundreds of gallons of fuel, and some of their bills are like $20,000, like in a day, depending on how much equipment they have. They're burning a lot of fuel to run all the equipment that they need, but they got a lot of different things. They got a lot of different equipment running through, and reducing that cost or having efficient machines that utilize that fuel better can actually save quite a bit of money, especially in a large operation. So when you think about the size of the machine that you need, right, you've got to have something that's going to be able to get the job done, okay, but not necessarily be overpowered for the job. You could have something, a 200 horsepower tractor, but if you're only using 80 horsepower or 50 horsepower, you've got a lot of machine that's going to be burning a lot of fuel just to run that engine, but you're going to be burning more fuel than if you maybe had a smaller tractor. Large tractors are nice because you can get a lot of acreage done pretty quickly. But the problem with a large tractor is it's going to be more expensive, and you really need to make sure that you're using this stuff, more than once or twice a year. If you only need a large tractor that's 200 horsepower once or twice a year, it may make more sense for you to use a custom operator than for you to, actually buy one and do that. Sometimes you can even rent tractors too. So you may not necessarily do a custom. You might go through and rent stuff. Um, but you got to make sure that you're going to be using those things to justify the purchase of a large tractor. These things can last 10 to 12 years typically, depending on the hours that you're putting on it. Tractors we don't categorize as far as miles like we do with vehicles, but we categorize them by how many hours they use. And we used to say, and I think it's kind of increased, like 10,000 hours on a tractor was, about the lifespan, 10 to 12,000. But some of those things have increased, and we can go up to like 15,000, up to like 20,000 hours of use before that tractor is really kind of deemed kind of dead. Kind of you think about that in terms of like miles on a car. You tend to have issues in a car, not a diesel engine, but a gasoline engine, typically around 140, 150,000 miles. And a car at like 200,000 miles, that's pretty much going to run its course. You're going to have transmission problems. You're going to have a lot of issues with those things. And tractors are very much the same way. So think about like, an hour as, what would that be? Like 10,000 hours would be like the equivalent of like 100,000 miles on a car in kind of today's standards. Smaller tractors versus larger tractors, they're going to cost less hours per run or to run those things because they're not trying to move this big equipment. They're not trying to, move this tractor, around. That's really heavy. It's not going to take as much, gasoline or not gasoline, but it's much diesel to be able to burn. And so it's going to be a little bit easier to run those things, especially if you don't need all of that horsepower of a big tractor. You might be able to trade these things at 6 to 8 years. The problem, though, that we run into with small tractors is that you tend to have less capacity, right? Which could cause delays. So how quickly do we need to get things done versus, where is our cost going to be at? The nice thing with small tractors, too, that's not necessarily listed on here, but small tractors have a little bit more maybe versatility when we're doing different operations. And so you may be using a smaller tractor more than you would a larger tractor. But we've got to look at that stuff. We've got to, identify those things and justify, what size tractor do we need to get? How quickly it takes us to get things done or the timeliness. Some things we need to consider is the weather. Is it going to rain? Is stuff going to dry out? Are we trying to plant? Do we need to get done quickly? How long do you have? Is there any kind of delays in production, late planting, late harvesting, that maybe we need to get these things done quickly? Sometimes you might need to get it done in a couple days. Sometimes you might have 2 weeks. If you have 2 weeks, you might say, you know what, we can slow it down and we don't have to worry about it. But if we need to, plant like right away and we need to kind of disc a field up, you may need a bigger tractor to get it done quicker. And then obviously like market problems, some things that you may have there. As far as custom operators go and why we would use one, typically if you have expensive equipment and low acreage, right? So if you've got expensive equipment, you don't have a lot of acreage, you're typically going to have a custom operator. Some people have, and especially here in the Valley, there's a lot of small farms that are only like, 100, 150 acres. And there are people that are going to be working, they work a full-time job, and then they kind of farm on the side. And some of those instances, it may not be even to like make spray applications. You may hire a custom sprayer to come in and spray your fields because you may not have the time and maybe you don't have the tractor, you don't have the equipment, you don't have the spray rig. It's going to make more sense. We're looking at basically, how much does the custom, operator cost versus how much would it cost to own that piece of equipment? When we deal this, obviously specialization, when we think, and this is probably like a really good example, or probably the best example that I can think of, is harvest equipment. A lot of harvest equipment has very specialized uses and can only be used, during harvest time. Okay. So you think about like the pistachio harvest, you think about that equipment that we use there. That's being used really one time a year, and that's it. We're not really using that any other time. Sometimes like on shakers for almonds, we might use them for almonds. We use them for walnuts. There might be some things that we have to adjust on that, but we can use the same equipment. But we do use shakers to shake off the mummies, which is like the dead almonds in the wintertime. So we really use shakers twice a year when we're dealing with almonds. But, is that twice a year justify the cost of that equipment there? The other thing is sometimes you may not know how to use it. You may have, the money to buy some of the stuff, but do you know how to use it? There's a lot of, details and fine work that needs to be done. If we're thinking about doing alfalfa harvesting, operating a swather is not an easy task. It's not like running any other tractor. It is quite a bit different. And then you've got the ability to kind of rake it and then to bale it and setting up a baler. If you guys have ever, I don't think we had a video on the baler, but balers are really complicated pieces of equipment, and you can't just jump into that and be like, "Yep, I know how to do that." To be able to get the weight, to be able to pack it right, there's a lot of information that you got to know, and if you don't know that, it may be easier for you just to hire a custom operator that knows what they're doing. That's what they do day in and day out, and they have that experience, and they're going to be way more efficient than what you're going to be. We think about the equipment and how often it should be traded. Pride of ownership. Like, you might have a tractor and you're like, you know what? I own this thing. I have it paid off. I don't want to trade this thing in and have another payment. You may just, just have that, like, hey, I own this thing and I don't want to have another payment. And that's fine, right? But how much is that going to, cause issues as it gets older? Are you going to have that downtime? Are you going to have to make those, repairs on that machine? They may have a higher production cost because you're going to drop your efficiency down. And we're going to talk a little bit about efficiency um, in a couple slides here and how we calculate some of those things out. But maintenance is probably the biggest thing, right? If you've got a tractor, and this is the same thing with a vehicle, and you're constantly putting this thing into the shop, okay, you're going to be spending a lot of money that you may be better off just trading that in and then getting a newer tractor. It may not be a brand new one, but it may be a newer one to you that has less miles, and it might be a little bit better. We actually did this at Fresno State. We had we needed to get a forklift out here because the old forklift that we had was just done. There was brakes didn't work, the hydraulics were leaking. There was just way too many issues with it for us to actually make a change. And so we ended up buying a new to us forklift, which had 10,000 hours on it, which kind of like a tractor, right? It's about half its lifespan, but we spent about half the cost on it. So we were able to get something a little bit cheaper. We don't need that forklift all the time. So we're not going to be putting a whole bunch of hours on this thing. And so for us, it made sense to buy a tractor or to buy a forklift that was, kind of, through, a decent portion of its life. But we're not going to be using it a whole lot. But when we need it, we absolutely do need it, to move metal, to do different things around the shop. But because we're not putting the hours on, that forklift's going to last us a long time. They don't necessarily degrade just because the years go on. It's the hours on the equipment that's a little bit, that's kind of harsh on it. We talked at the beginning of this class about doing like the pre-checks and stuff like that, checking the oil, checking the air filters, things like that. That maintenance goes a long way into extending the life of any equipment. If you neglect it and you don't put that stuff in there, it's going to be harder on it. If you don't do oil changes, it's going to tear that engine up and you're going to reduce the longevity of that piece of equipment. Government regulations is another one that kind of comes into play when we deal with government regulations. Probably the biggest one that's kind of in more recent history is the Tier 4 systems that we have for diesel engines, meaning that you can't run diesel engines that do not meet the certain emissions regulations. And if you have older tractors, you've got to get rid of those things and you've got to run things that have a Tier 4 engine in them. Depending on the size of the operation and all that kind of stuff, you might be able to get away with it, for a little bit of time, but kind of nowadays, pretty much anything that you have running needs to have a Tier 4 engine, which is going to meet those emission regulations. And it's specific for diesel engines. I don't know, the government kind of, attacks those because not as many people have diesel engines. So it's easier for them to put those regulations in place. I don't know if there still is, but there were some government programs to trade in tractors that did not meet those things, and they would give you a decent chunk of money to buy new ones. But a lot of farmers have had to upgrade their equipment because the government made regulations and essentially banned all these older engines that didn't meet those emissions controls. Some things that we want to think about when we're wanting to trade: the average cost per unit, versus the use, right? So how much are we going to get for the trade value versus what were we going to spend on the cost to repair it? If the repair costs are higher than the trade value, you probably just want to trade those things in because you're going to end up spending more money trying to keep a tractor running. Plus, you're going to have that downtime of that machine, and it's not going to work. If it's not reliable, you can't get things done. And in agriculture, timeliness is a really big deal. We are really kind of, held, by this, the environment that we're in, right? Is it going to be raining? Are we going to have water? Are we going to have a lot of heat? And different operations are really dependent on the time that things need to get done. If you have a machine that breaks down, let's say in the middle of harvest, and you don't get the stuff harvested, it's not like it's going to be there once you get the repair done, right? The fruit may rot off the tree and maybe, you don't get to, keep those things, and then you're losing all of your profit. So you got to think about the reliability. And then how does it affect your profit, versus your total farming operation, right? Is it using more money than what it would, cost to have a payment on a new machine? Those are just things you got to kind of think about. So to kind of watch some of these things and to make sure that we're kind of keeping track of this, right? We're going to use some of these management principles, like keeping records, right? Making sure that you have your machines done. Know how to accurately estimate the cost. How long should it take us to go through a field? How long should it take us to disc this field? Where are we going to be at? Are we utilizing this equipment to the best of its ability, or are we kind of really letting that stuff drain? And then how do we increase the equipment reliability and the unnecessary downtime? Because you are going to have that. You're going to have some downtime no matter what with any equipment. You're not running equipment 24/7. There is going to be some downtime, but how do we, maximize that efficiency to get the most out of the equipment and the time that we are dealing with stuff? So we can do this by improving our field efficiencies, right? That's going to help us cut costs. That's going to make things a little bit cheaper. You might have this, for example, let's say we have a tractor. Let's say it's a 50 horsepower tractor, and I can only pull, a 10-foot disc with this stuff. If I do that, right, it might take me X amount of time to be able to get that done. Okay. But maybe a larger tractor, I can get it done in half the amount of time and only increase my payments, by, maybe a third. Those types of things are going to help us utilize that equipment. We could even just be, going through and just getting out other inefficiencies with our field work, which we'll talk about in a couple of slides. Some of those things that are there. Having short-term, long-range plans, knowing kind of when we want to trade things in, when are we going to be repairing things. A lot of farmers will take kind of like this time. There, for most farmers right now, it's kind of a downtime, and this is really where a lot of them are going to go through. They're going to go through the machines. They're going to make repairs. They're going to go through and do that major stuff that maybe they kind of limped by, during the harvest time or during the busy time. And so right now, during this downtime where they're not running the equipment as much, they're going to take these things, put them in the shop, go through them, make sure that everything works. So that way, when it comes back around and we need to use them, day in and day out, those things are going to be good to go, and we're going to repair those things that need to be repaired. Things are going to break on tractors. That's just kind of a given. That's a natural thing that's going to happen. But when can we make those repairs, and can we avoid doing that during the busy times? And then efficiency and ownership. How do we do that? And that's kind of one of the things that we're going to talk about right now. So when we talk about machine capacity, okay, it's the rate of performance, or our field capacity, right? Is our acres per hour that we're going to be doing, and so that's how many acres we can do in 1 hour. We can also kind of categorize this as essentially speed times the width. So how fast is the tractor going versus what is the width of it? If it's a disc, how wide is the disc versus the speed? Similar to kind of the chemical, the spray applications. There's some similarities to these things, except we're not talking about putting out the chemicals necessarily in this instance. We're just talking about how much land can we cover, right? How many acres per hour can we cover in there? Now, I do have an equation here, and this thing looks really long, but I do have a simplified version of this on a Word document that you guys can use. And I'm probably should do a PDF version too. That way it doesn't mess up. I will add that into Canvas PDF version for those that maybe can't pull up the Word document correctly. But this equation, it's feet per minute times 60 minutes an hour times the width of your implement times 1 acre divided by 43,560 square feet. That's how many square feet are in an acre. This equation may look like it is, maybe a little bit large, but let me grab. That's the wrong one. That's not the one I want. Oh, no, this is the one I want. Okay. So simplify this thing. It's feet per minute times 60 times the width in feet, all of that divided by 43,560. So that's the same equation right here, as the one that's on that PowerPoint slide. This one just gives you a little bit more information, right? It's kind of where we get these things. But in reality, what we're looking for is how many feet are we moving per minute times 60, right? That's how many minutes, right, are in an hour. And then what's the width of the equipment? all of that divided by 43,560. I think we got some examples here that will kind of show you. So for instance, if we had a tractor that is got a 20-foot disc and it's traveling at 300 feet per minute, you might have that 300 feet. You would basically input these things into there. So it's 300 feet per minute times 60 minutes an hour. That's going to be a constant. Our width of our implement is going to be 20 feet. Times that by 1 acre divided by 43,560. You really don't need the 1 acre. That's really kind of unnecessary in this thing. If you input all those numbers, 300 times 60 times 20 divided by 43,560, you're going to get 8.26 acres per hour. And so that's the machine capacity. So at that rate that machine is traveling, basically we're going to be doing 8.26 acres per hour. So if you're running through a field and it's a 10-acre field, it should take you a little bit longer than an hour. If it takes you 2 hours to get through that field, we have some issues, going on with that piece of equipment there. And we want to kind of take a look at those things. Field capacity, obviously you can see there FC, we typically abbreviate for our field capacity. So just keep in mind, if you see some of those things, if you see FC, it's just dealing with field capacity there. Oh, I can't click over. There we go. Now some of the things I know we've kind of already gone over this a little bit, but speed of equipment is based on the job that we're going to be doing to give us the results that we need. Typical speeds that we're going to be doing for most operations is anywhere between like 3 to 5, maybe 3 to 6 miles per hour on a lot of operations. Some things we do go faster. We have some planting operations for like planting like silage corn that we can plant at 10 to 12 miles per hour. You're flying through a field going fast, but the equipment is designed to be able to do that. But like I said, most equipments, most cultivation practices, spraying applications, things like that, anywhere between 3 to 5, 3 to 6 miles per hour is about where we're going to be. This one says 4 to 7, but you get the idea. It's the same thing. Make a liar out of me, my PowerPoint. Anyway, we know this. We've gone through this equation, so I'm not going to kind of emphasize it too much. But the miles per hour, right, is the distance in feet per minute times 60 minutes an hour times 1 mile, which is 5,280 square feet, or not square feet, 5,280 linear feet. Which this all basically breaks down to 88 feet per. I think it's per minute. Let me look at my equation here. I've got this thing on here as well for you. I don't want to tell you the wrong thing. Yeah, 88 feet per minute equals 1 mile per hour. Okay, so that's all that this equation is telling you up here is basically it's 88 feet per minute is 1 mile per hour. So if we're going 2 miles per hour, right, that's going to double, right? It's going to be double 88, which is going to be what, 166 or 176? Yeah, 176. If we're going 176 feet per minute, you're going to be going 2 miles per hour. So we can use that thing to determine our field capacity, to be able to determine, our feet per minute, to be able to input that into the equation there. So on this one, right, if you're going 2,600 feet per minute, it takes you 5.4 minutes to go 2,600 feet. You take 26. You take 5.4 times 88, divide those together, and you're going to be able to tell that you're going 5.47 miles per hour. We'll have some equations on this that'll kind of help you kind of work through those things. But the biggest thing to remember is 88 feet per minute equals 1 mile per hour. Now, when we're doing this, we talk about our field capacity, and that's basically, how much the tractor can kind of do. We have this thing called our theoretical field capacity, and it's very similar to the field efficiency. But we simplify the equations a little bit. And this is kind of more of what we're going to use as a theoretical field capacity. We're going to use this equation probably a little bit more. And this one's a little bit simplified. It's a little bit easier to kind of use. We have our speed in miles per hour times our width in feet. So whatever equipment that we're running through that field, it's going to be our width. All of that divided by 825. Now we get that 825. You don't need to necessarily worry about a lot of this, but it's our acres per hour times, our acres per hour is our miles per hour times width, and our feet, 5,280, divided by or times by 43,560. It's basically the square feet, how many miles are in how many feet are in a miles. But the biggest thing, and this is going to be on your little sheet that you have as well, right here. I don't have all that, rigmarole. we've got miles per hour times width, theoretical, miles per hour times width in feet divided by 825. The 825 is a constant, okay? It is a constant. You don't have to worry about that. You don't have to stress over that. This is the equation for theoretical field capacity. So if we were to do this, pretty simple to put these numbers in. You have a 15-foot disc that's running 5 miles per hour. If we wanted to figure out how many acres per hour this thing would be able to do, we take our 5 miles per hour, input that, our 15, times those together, divide that by 8.25, and the answer is going to be 9.09 acres per hour. So that's how many acres that tractor pulling a 15-foot disc is going to go if it's going 5 miles per hour. Now we can increase that acreage per hour by, getting a bigger disc and running a bigger disc through if their tractor is going to handle that. We can increase the speed a little bit as long as it doesn't affect the job, and we might be able to get that acres per hour up. And so when we talk about our efficiencies in these things, okay, those are examples of what we can do to get a more capacity out of our tractor. On this one, we have a tractor that's pulling 5 shanks at 30-inch spacings at 3 miles per hour. This one, we should probably do this one together, actually, because this one's got a little bit more to it. So if we have a ripper and it's pulling 5 shanks and those shanks are 50 inches or 30 inches apart, one thing we've got to do is we've got to take 5 times 30, okay, because there's 5 shanks. We're going to get the width of this equipment. And we're going to be 150 inches apart from each other. We need to convert this into feet because our equation says that we need to have this in feet, right? It's width in feet, not just width. So we divide that by 12. It's going to be a 12.5 foot ripper. Okay, so we're doing 12.5 feet at a time. And we're going 3 miles per hour. So we can take that 12.5 times that by 3, right? And then divide that by that constant 8.25. Right. And we're going to get 4.54, or if we round up 4.55, that's how many acres per hour that we're going to be doing with that piece of equipment there. So hopefully that's a pretty simple equation. Like before when we talk about the spraying applications and stuff, the biggest thing that you're going to run into on some of this stuff is if you're running these things and you're not doing the conversion. So you figure out the inches that that's going to take up, like in that last example, but you don't convert that into feet. That's going to really mess your number up, and you're going to have a number that's going to be astronomically high. A lot of these things are going to be similar to each other. So our theoretical field capacity is, in theory, how much that tractor can accomplish at a given width and a given speed. Now, there are some things that we have to deal with that's going to affect how efficient we are going to be going through that field. Some things that are going to affect that is your machine maneuverability. So one of the biggest things, and you're never going to have 100% efficiency when operating a tractor, because if let's say we're disking a field, and we go through and we have to disc one side. We're going to pick that thing up at the end of that field. We're going to make our turn around, and then we're going to drop that disc back in the field, and then we're going to continue disking. Okay, depending on the operation, depending on what we're doing, that pattern and how we're doing that is going to affect that. So no matter what, because we're not just setting the disc down and running a straight line for that whole field, you are going to have inefficiencies where you're going to lose some of your capacity or your efficiency as you are running. Because when it's up out of the ground, that tractor, even for that 30 seconds or a minute or whatever that's out of the ground, that's affecting your capacity or your efficiency in that machine. So the field patterns that we do, the field shape, is it an oblong shape? Do we have to make more turns to kind of reset things up? That's going to affect those things a lot. How big is that field? If you've got longer stretches where you can go in one direction for a long time without having to pick equipment up, it's going to increase that efficiency a little bit. If you've got small short runs that you're going to make, you're going to have to make more turns. That's also going to kind of slow you guys. You're going to slow down a little bit. Yield and harvesting, what kind of the soil conditions, what kind of crop conditions are out there? Do you have a muddy field that's going to slow you down if you're disking through a field? That kind of stuff. We're going to talk about wheel slippage as well, but that stuff's going to come into effect, right? If we're not, if our soil conditions are poor, it's going to slow your operation down. And then just kind of system limitations. Is the tractor overpowered for what it needs to do? When we talk about EFC, or effective field capacity, we're kind of dealing with two different kind of equations here. And one of them, if we kind of take this top one right here, this acres an hour equals total acres divided by total hours. This one is, we kind of use this one in conjunction with our theoretical field capacity, to figure out where our efficiencies are at. This is done after the operation has been completed. So we take, we drive a tractor, let's see, we're disking a field. We can take how many acres that field is, we can divide that by how many hours it took us, and we're going to basically get our effective field capacity with that tractor. Sometimes what we want to do is we want to calculate what our effective field capacity is prior, or what it should be, where we would ideally liked it to be, and we can kind of compare and contrast. So this one's like an actual after the fact, where this equation down here is your miles per hour times your width times your feet, or your width in feet. This is like our theoretical field capacity, but we add in an efficiency factor here, and all of that divided by 8.25. So this equation is done prior to an operation to determine essentially where we should be at. And we can kind of compare that to the after the fact one, which is total acres divided by total hours. And we can figure out where we're at. Are we in, a good range, or did maybe that operator screw some things up during that stuff? The other one that you see kind of down here is our field efficiency. Okay. And so this is our effective field capacity times 100% divided by our theoretical field capacity. So that, in theory, without any turns, without any, tractor driver taking breaks and things like that, this is where our field efficiency goes through. So how much were we, did we do compared to our theoretical field capacity? So we're going to use the total acres per hours, right? And then our theoretical field capacity to determine what our actual field efficiency is. In the future, once you figure out field efficiencies of a certain operation, you can apply these things to this equation here. And so you could say, hey, we had a 90% efficiency the last time we disked the field here. We can plug that 90% into this equation here, use our miles per hour and our width to get an estimated time, or how many acres per hour we're going to be able to accomplish in a field there. So to improve our field efficiency, right, we can do these things. Like, so if we have a tank and we're only using part of that tank, right, or if we're only using a boom, if we're spraying and we're only using half of that boom, can we use the full width of that stuff, right? Can we increase the width of things? Filling procedures, like how fast do we do that? If we're filling up a tank for spraying and we take a hose, a little garden hose, and we try to fill up a 200-gallon tank, it's going to take a while. Maybe we need to have a 2-inch line or a 4-inch line that's going to supply water and fill these things up quick. Those are things that we've got to kind of think about. Unloading procedures, think about like the pistachios that we looked at, how they were unloading those bins and then grabbing new bins. How fast are we able to do those things? Is there a lot of hands-on stuff, or can we drive through and use equipment to pick those things up? We've talked about turning. We talked about the field conditions, right? Long roads, long rows versus short ones. As machines get clogged up, things are going to happen with machines, and they're going to get clogged up. We had a lot of issues when we were doing what we were doing. I think we were harvesting alfalfa, and we had some issues where the machine, the swather, just kept getting clogged up. I don't think the blades were sharp enough. I don't think the things were set up right, and it lowered it because when you do that, you're not going to cut a good field, so you have to stop. You have to clear it. Is your machine set up correctly so that way you can increase that efficiency? Making adjustments, right? Making the proper adjustments. We kind of just talked about that. Is it breaking down? How do we maintenance those things to reduce those? And then servicing the machines, to help, reduce those breakdowns are going to help. Obviously, stopping to rest is an important thing, but we don't want to stop and rest for an hour and a half. It might be only 15 minutes. How do we keep those short so that way we're not reducing our efficiency? And then if we're changing operators, sometimes you have operations that are going to go on that are going to need, to go, for, 16 hours, maybe even 24 hours. Do you have operators that are going to change? Are you going to drive the tractor into the shop, or are you going to leave the tractor out in the field and have that person come out to that field, so that way we don't have to take that. A car or a truck can drive a lot quicker to a location than a tractor can. Their tractors are a lot slower. And then we check machine, performance. We check those things. We look at that. We run the numbers. We make sure that our efficiencies are there. And if we start to see some of those efficiencies dropping, is it, something with the equipment? Is it something with the operator? Is the equipment unmatched, right? Is it too big? Is the equipment too big for the tractor? And it just is reducing that capacity down. I'm not going to do this, but these are some things that we maybe kind of want to think about. How do we do improve capacity for a forage harvester, for a swather, for a disc, for a chisel, cotton picker, right? Net sweepers. Think about some of those things, that you can. You don't necessarily have to do anything with this, but those are just kind of some examples, right? That we can deal with. If we have a sweeper, is our machine set up right? For the grape harvester, are we collecting and are we, removing stuff, uh, you know, at the rate that we want to do that? For a sprayer, can we increase the speed by increasing our nozzle sizes? Those are things that can, help improve our capacity to be able to get things done longer. So sometimes we have lost efficiency, and some of these things, I don't think we've talked about this, but we can lose efficiency in overlapping. If we're doing disking and we disc and we are overlapping our passes, we're going to be losing efficiency with each one of those passes, because we might say, hey, we have a 15-foot disc, but if you're not right next to that other line and you're losing even, 6 inches, that's going to reduce that time over that field, right? So our theoretical field capacity is quite a bit different than our effective field capacity, and that's going to change those things a lot. So to figure out our lost efficiency, if like let's say we're going through and we're disking a field, we have a 15-foot disc and it's overlapping 12 inches. Okay. Pretty simple. You can just take your inches lost in overlap. You can divide that by your equipment width in inches, times that by 100, and you're going to get a number. Let's run this thing real quick here. If we were to take, we have a 12 inches of overlap. Our equipment needs to be in inches. So let's actually get rid of that. Let's go 15 feet times that by 12 inches, because there are 12 inches in a foot. We have 180. So we're going to have 12 inches divided by 180. And we're going to times that by 100. And that's going to turn that into percentage. And we have our lost efficiency for that equipment is going to be 6.67% loss in efficiency. So just by overlapping that disc 12 inches, we would reduce our capacity from 100% down to 93.33%. And that's kind of be acceptable. We got to have to understand that your theoretical field capacity, we're never going to be at 100%. You are going to have some of that, but can we reduce that 12 inches down? How could we reduce that 12 inches down a little bit to make it a little bit less? What are some ways that we can make sure we're not overlapping 12 inches? Make sure you guys are awake. I'll ask a question here.
GPS?
GPS, that's going to be a real great one, right? Because GPS will put you exactly where you need to be versus just kind of running things by hand, right? If you're running things by hand, you don't have that GPS, that's going to reduce that overlap quite a bit. So what is our loss over that 12 inches, versus what a GPS unit costs? And you may be using it for other things, but, those are some things that we need to kind of think about. Is the GPS unit affordable enough for us to justify, increasing that efficiency by not causing that overlap? I can't say one way or the other because it really depends on the operation. But GPS really is a good thing, and you do use it for a lot. We use it for like the ripping that we did. We use it for planting. We use it, for a lot of different operations to make life a little bit easier for us. So we'll run through this equation here. So how long would it take us to finish 160 acres disking with a speed of 6 miles per hour and a 14-foot disc with a 91% efficiency? So this is our theoretical or our effective field capacity. So this is using this equation right here. That's using this equation right here. We've got that 8.25 constant that's going to be on there. Okay. And we're basically going to, put those numbers in. If we were to run these things, I didn't realize my equation was going to come up. If we were to run these things on here, 6 uh, miles per hour times, what were we doing? 14-foot disc, right? We're going to times that by 0.91. We do it by 0.91 because it's a 91%. We have to convert that percentage into a decimal. So you can just take that decimal point and move it over 2, or you could divide that 91 by 100, but it's going to be 91. So if you have an 87% efficiency, it's 0.87 whenever you're doing any of these multiplications. So we multiply all those things together. We divide that by 8.25. That's going to be our constant. And we get that 9.27 acres per hour. Now, this question is asking us, how long is it going to take us to finish this field? So what we need to do is we need to take that 160 acres. We need to divide that by how many acres we're going to do per hour, 9.27. And that field, that 160 acres, we should be done with that in 17 hours, and that would be 15 minutes. So just a little over 17 hours, right? If we're going through that field and it's taken us 24 hours to go through that field, there's probably something that's going to be wrong, because this is factoring in our inefficiencies. And if you're at 90% efficiency rate on a tractor, that's pretty good. That's where you want to be. If you're at like a 60% or a 70%, we probably have some issues, and we need to figure out what's going on. Do we have issues? Are the field conditions not good? Is the operator not good? Are they not doing what they need to do? Are they taking breaks? You're not necessarily going to go out into a field and watch these people do this the whole time they're doing it. If you're going to do that, you're not going to pay somebody to do that. You're just going to operate it yourself, right? So you're going to be out, you're going to be doing other things, but somebody's going to be doing stuff. And you've got to know, okay, that should take them a little over 17 hours to do. They might do that over a 2-day time period. So you might say, hey, if you're working an 8-hour day, right, you should be able to get that done in roughly about 2 days. If it's not taking them 2 days and it's taking them longer, you might want to look at that and say, okay, what's going on here? What issues are we having? Are they breaking down? Are they having to clear the machine out because things aren't operating right? Those are things that we've got to think about, but it helps you to figure out and understand where you should be at on the equipment, and what we should be, and what's actually happening in that field, without actually having to be out there watching them the whole time they're working. If you don't know, a good kind of rule of thumb is just to run like a 90% efficiency, on equipment. If you're like unsure of how efficient a piece of machinery should be, if you run a 90% efficiency, that's roughly where you should be at. You may be better than that. You may be a little bit worse than that. And that's okay. But if you're looking at this and you're kind of running these numbers, you're looking for things that are drastically farther. If this thing takes you, if it says, hey, it should take us 17 hours and 15 minutes and it takes you 18 hours, I wouldn't look at that and say, okay, we have a big issue. I would say, okay, you know what? Maybe they took some more breaks, or maybe, they had to wait to get the tractor filled up because it ran out of fuel and they had to do that. Those are things that aren't necessarily factored into that efficiency, all the time. But if you have something that's a big discrepancy, if you're supposed to be at 91 and you end up with a 75%, those are things that you're going to want to maybe look at and figure out, why did that happen and why did we lose that stuff? Uh, Machine capacity, right? The right size, needs to be matched with the work to be done. If it's not, matched correctly, you're going to have issues and your efficiencies are going to drop. Either the tractor is too small and your efficiencies are going to drop, or your, tractor is going to be too big and you're going to be spending too much money for what you need to be doing. So, matching those things and making sure that you have the right amount is important. We can do that by, determining what type of power that these things are going to take. Power can be in the form of drawbar pull, so that's going to be hooked up to the back of that tractor. It could be your PTO output, depending on what kind of operation. If we're doing a spray operation and it hooks up the PTO, and it could be your hydraulic systems. When we deal with this, I don't need you guys to worry too much about this, but understand that the work is essentially the force times the distance, right? And if we take 20 pounds times 3 feet, we get 60 foot-pounds. This is important to determine horsepower. So you don't need to worry about these things here. Don't worry about those numbers. But to determine horsepower, we kind of use, that work formula there to kind of figure that out. So it's force times distance. When we talk about 1 horsepower, we're talking about 33,000 pounds of feet that's going to be moved in 1 minute. Okay. Or how many feet are going to be moved in 1 minute divided by 60 seconds. Okay. We can also categorize this as 550 foot-pounds per second. So if I had a weight on the floor and it was 550 foot-pounds, okay, how much could I move that 1 foot, that 550 pounds? How much could I move that 1 foot in 1 second is going to determine my horsepower. Horsepower is kind of a funny thing because the 33,000 pounds was kind of an arbitrary number that was taken when they first were trying to figure out horsepower. They literally had horses pulling weight, and they had a horse that was a little bit smaller horse than what an average horse would be, and that horse was able to pull 20, I think it was like 27,000 foot pounds, or 27,000 pounds 1 foot in 1 minute. And they kind of said, hey, you know what? This horse is a little bit small. A bigger one should be able to move more. And so they came up with this 33,000 foot pounds. But in either case, we use that today. That's just kind of the standard that we have. That's the number, that 33,000 pounds. But we don't really deal with it too much. We deal with more with the horsepower, but that's kind of a little background. We don't need to worry about this equation, stuff like that. That's more of just some background stuff that's going to lead into some of these constants on these next two equations. So we've got drawbar horsepower and we got draft in pounds. So the first thing we're going to deal with is drawbar horsepower. This stuff is the force in pounds times the speed in miles per hour, all of that divided by 375. That 375 is a constant. We get that from the 33,000 pounds, right? So that's how much 1 horsepower is. Divided by 88 feet per minute, that's going to give us our 375. So you don't need to worry about how we get that. Just understand that if we want to do a drawbar, if we're trying to figure out how much drawbar horsepower something is going to need, we're going to have a force in pounds. And we might have 33,000 pounds. We might be running this thing at 2 miles per hour. We can divide that by 375 and we can determine what horsepower is needed. We do this if we're running a disc or a ripper, especially things that are going to have a lot of force and a lot of resistance. You're not going to get this with a spray rig. A spray rig is going to have really no resistance because we have nothing going into the ground. You typically are going to have maybe a trailering device that's going to have wheels, and you're going to have very little resistance. You can almost pull some of these things with your hand, and that's not going to be an issue. But when we deal with drawbar horsepower and like draft in pounds, we're dealing with stuff that's going to be basically sunk into the ground and creating resistance against that tractor. And so this kind of helps us determine what size tractor do we need. If we have something that's going to be, say 200 horsepower on the drawbar, because we know we have how much force, we know how fast we're going to run. If it's a 200 horsepower tractor that's needed, you want to make sure you don't get a 150 horsepower tractor because it's going to be underpowered for that equipment. Draft is going to be the same thing, kind of a similar equation to this because they are related to each other. If you have your drawbar horsepower, right, you have your horsepower times that by your 375, that's your constant, divided by your speed in miles per hour, you'll be able to tell essentially how much draft is going to be created from that piece of equipment there, depending on how much horsepower you have. Now, sometimes when we're dealing, well, not sometimes. A lot of times when you see a tractor and it's advertised at, let's say it's 200 horsepower, that is going to be dealing with engine horsepower. That is not your actual horsepower that you're going to be delivering to the ground, to your PTO or to your drawbar. What they do, and a lot of tractor companies do, and most of them do this, and you have to look when you're looking at your tractor. A lot of companies will label it as the engine horsepower because the engine horsepower is going to be the greatest horsepower that engine is going to create. The problem is when you take that engine and then you go into a transmission and you go into your PTO, it has gearing, and that gearing is going to reduce. You're going to have a reduction in power based on that gearing. And typically we say it's about an 87% factor or a loss of 13% on our PTO horsepower from our engine horsepower. So if we had a 200 horsepower engine, we would need to times that by 0.87 to figure out our PTO horsepower. So it's going to be reduced from there. Our drawbar horsepower is another 13% lower from our PTO because you've got tires and all that other stuff. You got additional gearing that it's going through. And so that tractor, typically it's roughly about like a 26% from engine to drawbar horsepower. So if you had an operation that was like, hey, I need a 200 engine horsepower at my drawbar to be able to pull this ripper through the ground, and you ordered a 200 engine horsepower, but you needed 200 drawbar horsepower, that engine is only going to produce 152 horsepower on that 200 horsepower engine. And so that tractor is going to be underrated for what you need. It's not going to be able to work like you want it to. And so those are the things that you have to kind of think about. Don't just look at the engine horsepower, because that doesn't tell you what power that we're going to have. You got to factor that 87%. And then again, it's an 87% factor from 174 to 152. That's just a rough, that's not like a steadfast number. That's not, built in stone. You may get a little bit more or a little bit less. It's just a general rule of thumb that we factor in 87% to figure out those horsepowers there. Oh, the last one that is kind of that we are affected by, and this one is probably a little bit more predominant than kind of like overlapping and stuff, and that's going to be wheel slippage. In a tractor, when we are running a tractor through a field, okay, you are going to have that tractor, those tires are going to be slipping in that field. No matter what you're kind of doing, you're pretty much always going to have some wheel slippage, especially as we're dropping things into the ground, rippers, discs, any kind of cultivators, things that are going to create resistance are going to pull on that tractor. And that tractor, those tires are going to be spinning, but it's not necessarily going to be moving forward. An acceptable rate of wheel slippage is anywhere between 10 to 15%. So if you have a 10 to 15% wheel slippage, that's okay. There's a simple formula that we can use on this, and that is to take the number of turns of a tractor. If you have a distance, in a field, and it doesn't matter what distance that is, but let's say you run it, 50 feet or 100 feet, and you do it with the tractor loaded. Okay, so you've got the disc in the ground, you run that, you can mark your wheel with chalk, you can count how many times that tire rotates. You can go through and do the same operation with the disc out of the ground, so you have no load on that tractor, and drive that tractor that same distance in that same part of that field and count how many times the tires rotate. The tires should rotate more when the equipment is in the ground than when there is no load on it. You would take the number of turns loaded for this example. Let's say we had 12 turns of the tire when it was loaded, and we had 10 turns of the tire under no load. You take 12 minus 10, times that by 100, and divide that by 10. In this example, it's going to give you a 20% wheel slippage. That would mean that that's going to be out of that acceptable range, and maybe we need to kind of take a look at that. Do we have that tractor in mechanical front wheel drive? Mechanical front wheel drive will help reduce wheel slippage. Is the tractor too light for the equipment? Is it undersized for that? Do we need to get a bigger tractor for those things? You do want some wheel slippage because it's going to help make sure that we don't put wear and tear on equipment. It's going to make the equipment last a little bit longer. So when you're dealing with like wheel slippage, as far as efficiencies go in equipment, you want to make sure that you're not focusing on trying to get 0%. Because if you have 0%, let's say that tractor is pulling a disc in the ground and you have a 0% wheel slippage, that means that the stress and the fatigue on that tractor is going to happen inside of the gearing. And that's not what we want to do. That's why we don't want to run mechanical front wheel drive on the road, is because the road, you're going to have very little to no slippage at all. And as those tires are turning, they want to kind of slip a little bit. It's going to cause those issues in the gearing systems. So slippage is really a good thing, because it helps kind of make that weak point at the base of that tire, where it's not going to do any damage to the equipment. Okay. And again, the area that we're kind of looking at is anywhere between 10 to 15% slippage. That's going to be okay. In this example, if I had, let's say I did this thing again, let's say I put mechanical front wheel drive in and the tire slipped 11 times, versus the no load 10 times. Right. And I would do that, times that by 100, then divide that by 10. I'm going to get a 10% efficiency. That would be acceptable. And it might be as simple as that, hey, I just need to kick the mechanical front wheel drive in to reduce that slippage a little bit. Because sometimes depending on the disc or something like that, that mechanical front wheel drive could have that big of an impact. Obviously, if you got a tractor and it slips and you've got 100% slippage, that means you are digging that thing into the ground, and you're going to bury that tractor. So if you're getting 100% slippage, you might want to stop the tractor before it buries itself completely, and figure out what's going on, so that way you don't get that tractor stuck. Cool. I know that was a little bit longer. That was longer than I was expecting to. I'm probably I'm gonna give you guys a little bit of a quiz that kind of deals with some of these things. We've got equations here that deals with our field efficiencies and different things. I may do a little video kind of explaining some of these things and then give you guys a little quiz to kind of test you on it. And I'll probably work with you guys a little bit too um, next week on these things, and we'll kind of dive into that. Maybe maybe what I'll do is I might just give you guys a quiz, let you do what you can, and we can kind of talk about it next class. That might make a little bit more sense to kind of let you guys go through. A lot of these things are pretty simple. Read the things, go through it. There's not as many conversions that we have to deal with like we do on the chemical side of things. But in either case, you guys are going to have a quiz later this week that'll kind of use some of these equations here. And we'll go through that stuff there. But we've got them all simplified. Everything that's in that thing, and even a little bit more simplified on the sheet. This sheet should be a lot easier. This is what I would suggest that you reference to, not necessarily that PowerPoint, just because there's a lot of different things in there that can kind of sometimes be confusing. So, yeah. So anyway, we'll do that. I don't want to waste any more of your guys' time, but I'll kind of go through and I'll help get you guys set up a little bit with those and with that quiz, and we'll work with a little bit more next week as well as the study guide. So if you guys have any questions, feel free to ask those things now.
Is that quiz going to be, you're just going to give it in the next couple of days and then do our best before next class? Is that what you're saying?
Yeah. Did I not share this freaking screen the whole time?
No,
We've been
but
looking
I
at
opened the
beautiful page.
PowerPoint so I could see it.
Oh my God. I just realized that. Somebody should have told me that you didn't see anything.
I was
Oh my
gonna say
gosh.
something, but I wasn't sure if you
Dude,
had it like on
say
purpose.
something. Say something to me. Yeah, I completely forgot that step, man. I just clicked on that stuff. Well, okay. That's gonna be interesting. I wonder how this video is gonna work. In either case, yeah. I wish I would have realized that before right now at the end. Cool. Well, yeah, you can pull up the PowerPoint and go along with that video, so that's good. But hey, I mean, I know this is like almost one of the last times, but if that happens again, just let me know before, so I don't make myself look like an idiot.
Sorry.
No, you're good. You're good. It's my fault completely. I completely like didn't even click on that, so it's my fault. But yeah. Anyway, so hopefully you guys got a lot of that stuff, and maybe I'll have to redo this thing and explain that all over again. Oh, that sucks. Oh well, it is what it is. So, you guys have any other questions?
If we do the quiz and if we have trouble on it, could we ask you on Monday?
Absolutely.
About
Yeah. So here's the thing with the quiz, that the quiz is not necessarily I want you to get the right. I mean, I want you to get the right answers, obviously, but it's more of a practice than it is like for points necessarily. You guys will be able to
Yeah.
redo that quiz to get the correct answers, so that way you can get 100%. So don't stress over the quiz as if you're like, okay, I got one shot to get this thing right and to do this. It's more of to get you guys to do it, so that way we can talk about it next week and see what we do. Because some of the stuff you may be able to go through, and most of you might be able to like, yeah, you know what, we got that, we understand that. I don't need to beat a dead horse and go over things if you understand it, because some of them are simple, some of them might be a little bit more complicated. So don't stress over the quiz, but do it so that way we can talk about it, and then you can redo those answers on that quiz to get the right answers.
Okay, thank you.
Any other questions?